Hi guys, it's Mrs. Milson. All right, let's do the check you understand on page 586, okay? We don't actually have to run a significance test or anything because it's already done for us in this nice little printout. The health director of a large company is concerned about the effects of stress on the company's middle-aged male employees. Now, according to the National Center for Health Statistics, the mean systolic blood pressure for males 35 to 44 years old is 128. The health director examines the medical records of a random sample of 72 male employees in this age group. The mini-tab output displays the results of a significance test and a confidence interval. So let's see if the results of the significance test give convincing evidence that the mean blood pressure for all the company's middle-aged males differs from the national average. Okay, and then we'll interpret the confidence interval. All right, so what does all this really mean? It's a one sample T. Okay, it doesn't say test or interval because it is a test and an interval. So it's a one sample T, test and interval. So a test of mu equaling 128 versus not equaling 128. So those are my hypotheses. Okay, now mu, before I move my paper up, what is mu? Mu is the true population mean systolic blood pressure for the company's middle-aged male employees. Okay, so my hypotheses are going to be mu equals 128, and I don't remember the units for blood pressure, so whatever. And then not equaling 128, okay? So I don't have to think about it. My hypotheses are right there. What's the alpha? Well, if it's a 95% confidence interval, the alpha for the significance test has to be 5%. Okay, so I got all that just from I got all my state done, okay? I'm not going to worry about the plan because, you know, they already ran the test. I assume all the conditions are met and we're good to go. We already know it's a one sample T. Oh, I'll write that. One sample T test. Okay, and now the do. Do I even need to calculate a T statistic or a T-score or a p-value? Nope, it's already done for me. My T is 1.10 and my p-value is 0.275. Now remember, this is a two-tailed test. So if I had my 128, my sample mean was 129, right? Or my sample mean blood pressure was 129, so I know that's over here. That's why my T is over here. But it's a two-tail, so I know I have to have the symmetrical area on the other side. But again, the printout's already calculated this stuff for me. There's my p-value. It's already taken into account that I have a two-tailed test. So now I really just got to evaluate that p-value against the alpha. Okay, so my p is 0.275 and my alpha is 0.5. And is that true? Absolutely not. Okay, 0.275 is not less than 0.05. So we're going to say our p-value of 0.275 is not less than alpha of 0.05, so we fail to reject the HO. So we do not have convincing evidence for the HA. So we do not have convincing evidence that the true population mean systolic blood pressure for the company's middle-aged male employees is different than 128. Okay, so we think they're all doing okay. They're all around 128. Okay. So here's my nice conclusion, exactly what I just said, okay? So if we don't have evidence that it's different than 128, we kind of think their blood pressure is roughly 128. We figure that 129 wasn't that much different than 128. So let's look at our confidence interval, okay? Now if we fail to reject the HO, we don't have any evidence that it's different than 128. We think it is 128, so 128 should probably be in the interval, okay? Oh, look, it is. Our interval goes from 126 to 133, okay? So our interval has 128 in it, okay? Which totally goes with our conclusion to our significance test because we did not have evidence that it was different than 128. So 128 should be in the interval. So again, everything works together. Okay, that's it for that one. See you all next time.